Hello guys, so we continue our discussion about integral equations. We actually stopped somewhere here where this integral part of this equation could actually be written as lambda or gamma j. Okay, where obviously we have gamma j. Okay, we have gamma j is this one. We have the integral of bj t prime, gt prime. Okay, we have dt prime. This is evaluated from a to b. Then we can then write this equation as, okay, this is the sum of alpha as a function of x. This is equal to, this is from I is equal to 1 to n. And then we can write, okay, we have this one, no? We have gamma I minus, we actually just have to transpose everything, no, on the right hand side. Okay, so we have times the integral of bi times t, this one, okay, times ft, okay, we just have to copy this one, plus lambda times the summation of alpha j t, okay, we have gamma j. Okay, this is from, okay, j is equal to 1 to n. And this is dt, and this is equal to 0. Okay, so here, the function, okay, the function alpha I as a function of x, okay, or the function, say, in general, no, the function, okay, alpha I, yes, that's it, as a function of x are linearly independent, okay, so we have gamma I minus beta I t, and this is evaluated from a to b, okay, times f of t plus lambda times, okay, we actually just have to copy this one. No? So we have alpha j times t, we have gamma j dt. Again, this is from 1 to n. J is equal to 1 to n. Again, this is equal to 0. And this is only possible now if our lambda I as a function of x is linearly independent. Because basically, if they are linearly independent, so we can just divide both sides by the summation. No? And eventually, this will be equal to 1. And 0 divided by anything is, of course, equal to 0. So what's left is this one. Okay, so we have, this is for I is equal to, again, now this is I is equal to 1, 2, up to n. Okay, now using the simplified notation, okay, or we can actually simplify this one. So we have using the simplified notation, okay, this could be written as, we have integral of bit, okay, ft dt. We could just write this one simply as fi. Okay, this is evaluated from a to b. And then we have the integral of bi t, this is t, alpha j times t as a function of t dt. This is evaluated from a to b. And this is equal to, maybe you can just write or name this one as gij. Okay, this is gij. Okay, so where fi and gij, where fi and gij and Gij are known constants. So these are known constants. Known constants. Okay? So we have gamma I minus Fi, or gamma I, okay, minus Fi minus lambda times the sum of gamma j, Gij. This is now equal to 0. Again, this is from 1 to n. Okay, so we have gamma I, this one, and then we have Fi, which is this one. We have, this is Fi, and then we have the remaining terms, this one. Okay, we have, of course, we have to distribute this one. So we have beta I times alpha j, and that is Gij, and this is equal to 0. Okay, so this implies that Fi, okay, is equal to, just transposing this one to the other side of the equal, we have this one. So this is equal to gamma I minus, again, this is plus, okay, Fi. Okay, so we have minus lambda times, okay, the sum of gamma j. Okay, we have gamma j, Gij. Okay, this is from 1 to n. Okay, so this means that we can have, okay, a system of n algebraic equations, equations for the unknowns, we have for the unknowns gamma I. Okay, so this is all about integral equations, particularly Fredholm integral equation. What we solved here is actually the Fredholm integral equation, where we just expanded it by using the form of the separable kernel, which is in summation form. And of course, we can apply the same to Volterra integral equation, because we actually just have to change the limit. Now, as we can see in the Volterra integral equation, the limit is actually, instead of from a to b, so we just have to change it from a to x for the Volterra. No? So here is the Volterra. Where is it? This one. No? So we have the Volterra is from a to x. Okay, so I guess that's all. We will be, on the next part of our discussions, we will be solving some examples that use this Fredholm integral equation and Volterra integral equations. Stay tuned.